Okay, this next one is question 2. For this, you were only going to look at part A because part B is looking at volume, and that will not be on the 2020 exam. And C, that is looking at the area between two functions, which will also not be on the 2020 exam. Part A is asking for the area of R, and since that is the area between the function or functions and our x-axis, that will be seen on this 2020 exam. So when looking here, it says let R be the shaded region in the first quadrant bounded by the x-axis and those two graphs. As shown in the figure, find the area of R. So if you're doing this in the x direction, notice that both those rectangles are not hitting the same function the entire time. So you're going to have to do two separate integrals, one for this shaded region over here in yellow, and the other for this shaded region in green. And because if you look at those rectangles, notice the height of the one in yellow is touching y equals ln of x, and the one in the green shaded region is touching the line y equals 5 minus x. So since the height, the top of those rectangles aren't touching the same function the entire time, you do have to do two separate integrals, okay? So for the one in yellow, we're going to go 1, 2. We have to figure out this x value right here. So you do have to figure out that intersection point. And again, this is on a calculator. So I would say graph y1 equals ln of x, y2 equals 5 minus x, and calculate where they intersect. Okay, by doing math, calculate number 5, I think is intersection. And when you do that, you will want to make sure you are writing out the full decimal. And what you can do, so you don't have to keep typing it out, you can say, you can let that equal a variable if you want, or you can store it in your calculator. But that's going to be your upper bound for the yellow region. And remember, we don't want to round during problems because then our answers in the end will be rounded and they will be off and you will not get credit. So you do need to make sure if you're doing it this route, you got to use that full decimal that you get from your calculator. So that's the top part of that yellow region is ln of x dx. And then we will go from that same x value to right here, which is 5. And this is a calculator portion, so you can just plug the 2 into your calculator and you end up getting 2.986. If you truncated it to the 3 decimal places, it's just 2.985. Okay, so that's it for that one. This one's actually easier if you do it in the y direction. So I'll redraw it here so you can see it. I'll do it in blue. And the reason why it's easier is because if you look at your rectangle, no matter where you put it, up and down, the left side is always touching the natural log function. The right side is always touching the line. So to solve for the line in terms of x, it would be x equals 5 minus y. To convert ln of x, or y equals ln of x into the form of x, you would just convert it into exponential and it'd be x equals e to the y. And you would need to know your highest point, so that would be the y value. So your integral would just go from 0 to that y value. And you would go from the right side, so 5 minus y minus the distance to the left, which is your e to the y. And again, you would do math 9, and it's going to give you the exact same answer, okay? So nice part about doing it that way in the y direction is you only have to set up 2 different integrals. Again, part B and C will not be on the 2020 exam because they said nothing out of their Unit 8 will be included, and both of those are in their Unit 8. So that is it for question number 2.